Alright, let's continue. So here's a couple more examples. Let's look at the sum from n is equal to 1 to infinity of just 1. So again, we're going to use the partial sums. So Sn is equal to the sum from n is equal to 1 to big N of 1. So this is by definition 1 plus 1 plus 1. So I'm adding 1 to itself n times. So there are n terms in this sum. So this is just n. So you can see that the limit of Sn is equal to the limit of just n, which of course is infinity. So this sum diverges. Okay, which makes sense. If you add 1 to itself infinitely many times, you would expect to get infinity, right? Here's another example. This one is a little bit weirder. Let's look at the sum of negative 1 to the n. So this is equal to, by definition, negative 1 plus 1 minus 1 plus 1 minus 1 plus forever. So on one hand, you might think that this cancels with this, and this cancels with this to give you 0. So does this equal 0? On the other hand, this might cancel with this, and this cancels with this to give you negative 1. Or it could also equal 1 if you group them in a different way. So it's not really clear what the value of the sum is. But we're just going to use the definition, the partial sums. So this is equal to n is equal to 1 to n of negative 1 to the n. So this is equal to negative 1 plus 1 minus 1 plus 1 minus 1 plus all the way up to plus that. So this is equal to, this has n terms again, right? Okay. So I think you can see that if n is even, all these terms will cancel out, and I'll get that Sn is 0. On the other hand, if n is odd, Sn is negative 1 because there's 1 left over. So if you just think about the limit, if you plot Sn as a sequence, so here's n, and this is Sn. This guy jumps back and forth between 0 and -1. So it looks like this. Okay, so you can see it never levels off to a limit. So this guy has no limit. So Sn diverges. Remember the definition of a sequence? If it has no limit, we say it diverges. So this sum here this also diverges. Okay, it doesn't diverge to infinity, but it just doesn't sum to anything. Okay, so infinite sums are pretty weird. Okay, let's look at another example. This is the example that I started with. This is called the geometric. Okay, so here's the geometric series. I'm going to take R to be a positive, well, it doesn't have to be positive, just a real number. And I'm going to, also C. Okay, so C and R are constants. Okay. So my geometric series looks something like this. N is equal to 0 to infinity, CR to the N. Okay, so this is equal to C plus CR plus CR squared plus CR cubed CR to the N, and it just keeps going. Okay, so we want to figure out what the value of this, if this limit converges, and if it does, to what. Okay, so does this converge? And if it does converge, what does it converge to? Okay, so again I'm going to use the partial sums. So Sn is just equal to C plus CR plus CR squared all the way up to CR to the big N. Now look at this. If I multiply Sn by R, this is equal to CR plus CR squared all the way up to CR to the N plus 1. So I'm just multiplying every term in here by R. Okay. Now look what happens when I subtract them. So Sn minus Rsn is equal to, well, when I subtract them, this is going to cancel with this, and this is going to cancel with this, and everything's going to cancel out. Even this is going to cancel with the one previous to it. And all I'm going to have left is this and this. So this is going to equal c minus cr to the n plus 1. Okay, now I can factor out Sn, so I get Sn times 1 minus r is equal to, and so I'm going to factor out c, 1 minus r to the n plus 1. So I'll just divide to find Sn. Okay, so now I want to take a limit, right? Now I'm going to take limit as n goes to infinity. And I'm going to use what I know about a geometric sequence. Okay. So let's look at the cases. Okay, so if r is bigger than 0, or bigger than 1, say, this term is going to go to infinity. Okay? So that comes from the geometric sequence. This term here will go to infinity, and so the whole thing diverges. Okay, if r is equal to 1, then you can see that it also diverges, because I would be adding up I would be adding up 1 infinitely many times, which we already know diverges from up here. So it also diverges in this case. So what's left is if r is less than 1. If r is less than 1, this guy will go to 0 as n goes to infinity. And what do I have left? I just have c divided by 1 minus r. So this is the formula for a geometric series.